for this next lesson on systems, we're just going to determine which method is best. We have three methods. We have graphing, we have substitution, and we have elimination. But you have different types of word problems, or different types of problems. So how do you know which one to use? Now, you can use any method, absolutely any method. They all work, they will all give you the same answer. But some of them are easier than others for specific problems. So you are never going to be forced to use one of these methods if you hate it. But some of them are just easier, for instance, using elimination or substitution. So this little chart will help you figure out which is the easiest way. So if both equations are solved for y, and it has to be y, or they can be easily solved for y. And key thing here, they can be easily graphed. So easily graphed means you want to have small numbers. You want to have preferably not decimals. Fractions are okay because that's a rise over run, but preferably not decimals. So if you see something like this, small numbers, you can have a little fraction, but no decimals, your easiest method is going to be graphing. That does not mean you have to graph. That's just going to be the easiest one. Okay? If both of them are solved for y, but they're difficult to graph because they're large numbers, they're decimals, anything like that, I would not do graphing. For this, substitution is going to be your best bet. So you would box one of them up and then take it to the other y value. So you'd have x minus 375 equals 175x plus 450, and then you'd solve for x and plug back in. If both of your equations are solved for x equations cannot be graphed. So for this one, substitution is going to be your best bet. If only one equation is solved for x or y, doesn't matter, your best bet is going to be substitution. Because you can box this up and plug it into the other x. If your A, B, and C are aligned, meaning they're in standard form, whether you have opposite coefficients or you have to make opposite coefficients, if they are in standard form, your best and easiest method is elimination. Elimination. So if they're in standard form, elimination. If they're not in standard form, substitution. If they're small numbers, really, really easy to graph it. But graphing is probably going to be your rarest one. So let's look at these. What would be your best method? Well, if I look at this equation, this set of equations, only one of them is solved for x. The other one's not solved at all. So this one, I would do substitution because one of them's solved, so I can substitute it in for the other. On number 2, how many equations are solved? None of them. If they're in standard form, elimination is your best bet. Number 3, how many are solved? Both of them. They're both x equals. But x equals cannot be graphed. So because they're already solved, we can do substitution, but we can't graph it. Number 4, how many are solved? Both of them. Are your numbers small and easy to graph? Yeah. So I would graph it. You got your slope, what is this? Y-intercept, and you have your rise over run. That's easy to graph. Okay, on number 5, how many are solved? None of them. So I would do elimination here. They're both in standard form. Number 6, how many are solved? None of them. They're both in standard form, so I would do elimination. Number 7, how many are solved? Actually, the first one is solved. It's at the back, but that is solved. So you can box it up and plug it into the other y. So for that, we would do substitution. Number 8, how many are solved? Neither. Now you will have to distribute this 5 out, but then it will be in standard form, so you can do elimination. And then just a little extra review all the way back from the first lesson of this chapter. Remember that if your system has the same slope and different y-intercepts, the same slope but different y-intercepts, that's going to have no solution, because those are parallel lines, which means they never ever cross. If you have the same slope and same y-intercept, those are literally the same equation, so they're always going to cross. So they have infinite solutions. Those are called coinciding lines or overlapping lines. And if your slopes are ever different, it doesn't matter what your y-intercept is. If your slopes are different, you're going to have one solution. Those are just called intersecting lines. So they literally just cross one time.